Hello and welcome to this episode of Microchips. In this episode we will be converting a WEMOS D1 Mini Pro to work on an external antenna and doing the first build of the Christmas light controller. So what we have here is the WEMOS D1 Mini Pro with an internal antenna and an external antenna connection, and what we'll be doing is moving the 0 ohm link. And here you can see the 0 ohm link that has to be moved. That is the internal onboard Wi-Fi antenna, and if we move across we will see the external Wi-Fi antenna connection, and luckily this unit comes with an external antenna which should improve the range. So looking down, there's a capacitor that then goes straight into the ESP chip. So the 0 ohm link is the one we'll be moving, so let's get the hot air station out. And there, it's as easy as that with a hot air station and a microscope. But the problem I had there is that I couldn't actually look at the board, I had to look at the computer screen to position the component. And here we have the board, so let's start assembling the board. First off, we need to connect the legs to the ESP unit. I'm using the board as a template, so all the legs will line up when I place the sockets onto the board. Quick clean of the soldering iron, and let's solder the legs into place. I always like to start off in the corners so you can get everything nicely lined up, and then go down each one of the connections, make a nice solder connection, just like that. Now it's time for the pins for the relay unit. As there are not many pins that are used on the relay unit, I thought it would be easier to use the least amount of pins possible. So if it ever needs removing, there's not a massive amount of pins to desolder. Plus, using those extra pins in the corners helps with stability and make sure it doesn't ever fall off. So again, we're using the board as a template, putting the relay on top, and then soldering the pins onto the relay unit. Now I've added some flux to the position where the level shifter IC will be placed. So now I'm going to manually tin the place where the level shifter will go. If I tin it first, it helps when we come to actually solder the level shifter onto the board, because at the moment there's not really a lot of solder actually on the connections when they come from the factory, so it's either that or use solder paste, but I find this way is a bit easier. Plus it kind of puts a nice level of solder onto the connections, and also as well we've put some solder onto the position where the 220 ohm resistor will be, and I've accidentally caught the position where the capacitor lives. I'll be cleaning off all the flux residue with some IPA alcohol after, but for the moment we're just going to tin it up, get all the pads nice and level, and then we will hot air the level shifter IC on. We'll heat the board up and heat the pads up, and as soon as it looks like it's melted, we'll drop the IC into place. Then we'll go over with the hot air, and we'll go over it with the soldering iron as well, just to make sure. Because really I should have used a bigger hot air tip for this, because I was still using the same tip as I was using for the Wi-Fi mod on the ESP unit. So we'll add a little bit more flux, and we'll quickly go over it with the soldering iron and visually inspect it after that, but everything should be good. With the amount of copper that's actually on the board itself, it dissipates the heat away very quickly, so that's why I'm just going over with the soldering iron, just to make sure that everything is soldered correctly and in place. And now it's time to fit the 220 ohm surface mount resistor, which we'll just use a soldering iron for this. Don't need a hot air gun. It's a 1206 package, so it's big enough to manually solder into place. Even though this is going to be covered with the ESP unit, I still like to get it lined up as best as possible. A little bit of pressure from the top just pops it into place nicely. There we go. Quick clean with IPA and it's all looking nice and tidy. I've also fitted the decoupling capacitors and the main capacitor from the 5V supply, so we'll just quickly solder those into place, Again, it makes it hard work when soldering the negative side because of the sheer amount of copper that's on the board. It dissipates the heat away very quickly, so you have to keep your soldering iron on there for quite a while before the solder will actually flow into place. Now it's time to fit the ESP unit with its socket, so I've already pre-installed the sockets onto the base of the ESP unit. We then fit it to the board, hold it in with a little bit of blue tack, and again we'll just solder a corner, and then we'll apply some pressure from underneath, push it whilst heating just to make sure it's located correctly, and again we solder a corner, place some pressure from underneath whilst reflowing the solder, and the job's a good one. And then we'll just go along the pins and solder them. Again, the earth connection is going to take a little bit longer for the solder to flow. It's as easy as that. And we're going to use the same method for fixing the relay, but we're not going to put it in a socket this time. We're just going to solder the pin straight into the board. So again, we'll locate the relay, pop a little bit of blue tack to hold it into place, and again we will just solder one pin and then readjust it before we finally put the final solder onto it. There's only 3 connections that are needed for this relay unit. There's the activation pin, 5 volt and ground. All the rest of the pins are just there to hold the board into place. I could have used just 1 pin on the other corners, but I thought it'd be easier just to use 2 pins, because then it lines up nice and tidy. Here I fitted the 2 wires from the normally open side of the relay. I know you may think, well, why has he used a terminal block when there's clearly a terminal block on the relay? It's because I wanted to put all the connections up on the end of the board, and just because it looks good. It serves no purpose other than to just bring the connections to the edge of the board. But when you're designing a board for your own use, it's however I want to design it, basically, and this is how I wanted to design it. And I think when it finally goes into the boxes that I've already made with the older board I made, that it should just slide into place with minimal amount of rewiring. And again, we're going to solder the blue terminal blocks in, and yet again we're going to have to use more heat on the negative connections due to the massive amount of ground plane, copper ground plane. That's one advantage of using a gas iron, is that you can crank the temperature up and it will deliver the heat nice and quickly. I do like using the gas iron because it's quite versatile if you know how to control it, and as you've seen, it can solder even the smallest of components relatively easily. And it does allow you to switch tips out. If I wanted a really big chisel tip on the end of it to deliver massive amounts of heat to the component, I could easily do that without a problem. But for me, this is nice and easy. Just deliver the heat to the joint, add the solder, and wait for it to flow. And once I've done this, I will give it a quick IPA bath to remove all the flux and tidy the board up. As you can see, I'm having a little bit of trouble with that connection, but eventually it does finally tin and connect. And there's the finished board. Quite compact, looking all good. I made it exactly the same size as my other board, so like I've just previously said, when it goes into my box, it will just slot straight in. There's a level shifter underneath the WEMOS. And now let's test the unit. So fitted all the components, put on a pre-programmed WLED ESP unit out of one of my other test units, and we power up and bring the exposure down. It's very hard to try and get the true colours to show of the 64 LED panel, so I'll try my best, but when it switches on, it comes on like an orange colour. So there's the WLED interface, and it's on solid colour at the moment, so hopefully you'll be able to see. So we can adjust the brightness. It doesn't come across on the camera very well actually, and there's some of the patterns. And all these patterns are available via MQTT. So if you wanted to use something along the lines of Node Red to synchronize different units, you could do. This WLED also comes with a sync button that allows you to sync units of the same firmware together, which is quite handy, so you'd only have to point MQTT at one unit and have that unit synchronizing. But if you wanted different patterns on different units, I think you'd probably have to have them single and have MQTT controlling each one of them, which is easy enough via Node Red. So as you can see, the WLED has got a massive amount of preset patterns, much more than the other firmware I was using. But the other firmware, Tasmota, is brilliant, but it's meant for everything, sensors and everything to do with home automation. This firmware WLED is primarily made for the controlling LEDs, and as you can see, some of the patterns on it are amazing. In fact, all the patterns on it are amazing. You can switch between all different shapes. Some of them look good whilst on a square like this. Other patterns look good whilst on an LED string, which is more useful for going around windows. So let's program one. So we plug a USB into the WEMOS unit. We've got Node MCU flasher. So we'll select browse. We select the latest firmware for WLED. Click open. We've refreshed the COM port to make sure. We select D out, and I always like to hit erase first so it erases the onboard flash memory, so there's no stray code or settings left floating about. And because it's a 16 meg flash, it does take a while to erase, but once it's erased, not a problem, it will flash in no time at all. And there we go, it finally flashes. I'm going to keep this program open because I like to save what the MAC address is, because it helps for initially finding the device on your home network, because I like to put static IP addresses on these units. So when I'm using a network scanner, I can look at the MAC address of the scanned item and actually find the unit that way. Especially when you've got a lot of devices on your network and a lot of unknown devices, it helps. So I was going to start using the network scanner, but then I thought, okay, I haven't actually paired it up to my home network yet. So we'll keep a note of the MAC address. And there. Now I've actually omitted the part where we pair it up on the phone, because basically you have to connect to this unit with your phone and then set the Wi-Fi settings basically on the phone, and then once you save and exit that, once you've put your SSID and a password in it, and connects to your home network. So now it's actually connected to the home network. We've got lights on the unit, and we're going to set a static IP address. So we'll type in an IP address that I've allocated for this unit. We'll set the subnet mask, and we'll set the gateway as well. We'll also turn off the Alexa Home Assistant, because we won't be using it that way. And we're going to set the MQTT configuration as well. Make sure the group topics set correctly, make sure the individual topics set correctly, and make sure the correct IP address for the actual MQTT server that I have running on a Raspberry Pi. Save and connect. We type in the new IP address, and there we go. We're back into the interface again. Quickly check the lights are operational. Now you saw all the lights weren't on, so we have to set the amount of LEDs. So on this one it's 64. So you'd set the amount of LEDs you've got in your string, hit save, there's all the LEDs lit up. Bring the brightness down so it doesn't draw too much current, because 64 LEDs running at full powers draws quite a bit of power, especially when they're on white. So let's have a look at the configuration. So we'll click on Sync Interfaces. We're going to make sure that the relay is switched on, so we have control of the relay. We're going to turn off the Alexa device. We're going to enable MQTT. I seem to have cut that bit a little bit short, but never mind. Here's a project from a couple of years ago, which was a Christmas tree I designed, and it was using some home software, but now we've got WLED. We can convert this to using WLED. So I've got both of them hooked up and working, and you can see the pattern on the board I've just made. If we click sync, then the Christmas tree synchronizes with what I'm controlling there, which is very, very handy. So all in all, a successful build. Very happy with the board, very happy with how I've designed it, and it should function just as good, if not better, than the old one. The reason why I put the relay on the board is so it can cut the power to the LED strip totally, instead of leaving the LED strip with electricity on it. And here we have the bigger brother to this unit, which is basically 3 of the same, but that will be used for controlling obviously 3 light strips at once. So I hope you enjoyed this episode of constructing and testing this board, and thank you, and see you in the next episode.